So hello friends, this is Tichu, and in this video we are going to discuss all about bit manipulation, right? So before starting this video, I want to mention this that I am making this video considering competitive programming in the mind. So if anybody wants to start problem solving in bitwise manipulation, then this is the perfect video and enough for starting with any bit problem. Okay, so now let's understand. So before moving on this video, let's first understand what is a bit. So a bit is basically a smallest unit in which a computer store his information, right? So a bit can have a value, either it is 0 or it will be 1, right? So a bit can have two values, either it will be 0 or it will be 1, right? So now let's understand some LSB MSB concepts. Like suppose this bit series given to you 101000, suppose, then the rightmost bit which you are seeing we termed as LSB, and LSB stands for lowest significant bit, and the leftmost bit is termed as MSB. And MSB stands for most significant bit. So these are some terminologies which you should know before doing these problems, right? So now let's start. So next we will see how to convert from bit to decimal form, like bit to normal numbers which we see like 48, 50, whatever it is, bit to normal number, how we will convert it. Okay, suppose this bit is given to us 101011, suppose this is given to us and somebody is asked to convert it into normal number. So how we will do? So let's first understand this naming thing also. Like this first bit which you are seeing, we called it as a 0th bit, and this will be the first bit, this is the second bit, this is the third bit, this is the fourth bit, and this is fifth bit, right? So we say these bits as this, like this is the 0th bit, this is the 1st bit, this is the second bit, this is the third, this is the fourth, and this is the fifth bit, right? And now let's see how we will convert. So we do nothing. What we will do, we will take this 1 and multiply with 2 to the power 0. So basically this is going to be the contribution of this bit in this number, in this whole number. So similarly what we will do, 1 multiply by 2 to the power 1. So basically this 0, 1, 2, 3 is going to be the index x which you are seeing on the top, right? And so similarly here it is going to be 0 into 2 to the power 3, 0 because here it is 0, sorry, here it is going 2 to the power 2, right? So 0 because here it is 0, and now 2 because the power was 2. Okay, in the similar fashion we will do 1 multiply by 2 to the power 3. Okay, in the same way, right? Let's do now faster. So it will become 0 into 2 to the power 4, and it will become 1 into 2 to the power 5. Now just add all these things. Now the number which you will get is going to be our decimal number, right? Let's first add it also. Like this is going to be 1 2 to the power 0, 1. From here we will get 2. From here we will going to get 0. From here it is going to be 8, and from here it is 0, and from next time this is 32. Okay, so the whole number equals to 43, right? Okay, so now let's understand. So this is how we convert from decimal to, so this is how we convert from binary to decimal, right? Now let's understand how we convert from decimal to binary, right? So for example, let's take the previous one. 43 was there. Now try to convert in binary. This is what our problem is, right? So the logic which we use in competitive programming world, we will try to use that. So what we do, for example, here it is 43. We will first divide it by, we will first see the remainder when, if we divide it by 2. Okay, so clearly when you divide 43 by 2, you will get remainder 1. So write 1 here, and now divide 43 by 2. So it will become 21, right? You are not going to write it like 21.5. You have to take the lower bound of in integer value, right. So now again ask 21 that what is the remainder if I divide u by 2. So it will say 1, right, and again divided by 2, you will get 10, right. Now ask 10 what is the remainder if I divided u by 2. It will say 0, and you will get, and now again write it like dividing by, after dividing by 2 it become 5. Now from 5 ask what is the remainder if I divide by 2. It say 1, so it become 1, and now just divide it by 2 and write it here, it become 2. And from 2 now ask what is the remainder. It will say 0, and just divide it by 1. And now from 1 ask what is the remainder I will get if I divide it by 2. It say 1, and then divide it by 2, it will become 0. So until this number is 43 is not becoming 0, you have to follow this process, and you will get this binary representation. But one thing remember, that you have to write this from right to left. Okay, that this one is the remainder which we got from 43. Okay, this one is from 21, this 0 is from 10, this one is from 5. So from right to left you have to write. Okay. One also cool thing which you can see here is, like, if you want to write directly that what is the bitwise representation for 43. So what we can do, just think what is the maximum 2 to the power number which is inside this 43, which is like less than or equal to 43. Okay, so you can see this is 32, right. So directly just subtract 32 from 43, right. What you will get? You will get 8, 3, 11, right. Now ask 11 that what is the maximum 2 to the power thing which is inside this 11. You will say 8, right. So that is why you have 1 at the 8th place. Like, what is this? This is 2 to the power 3, or 2 to the power 3 is nothing but 8. So that is why you have 1 here. Understood? Now just remove 8 from here. You will get 3. Now ask from 3 what is the maximum power of 2 which is less than or equal to 3. So you will say like 2. Okay, and that is why you have at 2, because this is 2 ki power 1 which is nothing but 2. So that is why you have 1 here. Okay, and then subtract 2 from 3, you will get 1, right. And now ask from 1 what is the maximum 2 to the power is 2 to the power less than or equal to 1, which is obviously 2 to the power 0, and that's why here we have written 1. Okay, so just understand the concept. What we have done, we have just written 1 at the maximum power of 2, which is less than or equal to our remaining number, right. And then we have written just 0 in the remaining places, right. So this is how we can do to convert it back into a binary number, right. Okay, now one second. Okay, what happening? Okay, so this was it, and now let's move on to the bit addition part, that how we do bit addition. Okay, bit addition. So the concept is very simple. For example, if you are adding 0th bit to 1, it will give you 1, right. If you are adding 0 to 0, it will give you 0. If you are adding 1 and 1, so 1 and 1 will make 0, and a 1 carry forward will go in left, so you will get 1 0. Okay, but suppose if you have to add like double 1 and 1 carry is coming from the back, so what will be the answer? So answer will be very simple, like 1 for 1 1, you know it is going to be 1 0, and the carry which is coming from the back, it will basically just at this bit in place of 0, it will make it 1. So I mean to say, like, if you are adding 3 1 at a place, so it will nothing but 1 1, because you can see also like this is 2 to the power 0, and this is 2 to the power 1. So the overall value will be equal to 3, which you are adding here, right? So this is the concept of adding, right? And now let's move on to the subtraction part. So before subtraction, let's understand there is a 1s and 2s complement thing here. Like what is 1s and what is 2s? So 1s is nothing. 1s is basically doing a NOT gate of given current bit, given bits. So for example, if it is given 1 0 1 0 1 and somebody is asking you to write it the 1s complement of this, so you have to do nothing, just in place of 1 write 0 and in place of 0 write 1. So it will become 0 1 0. So this is basically the going to be the 1s complement of this 1 0 1 0 1, right? And the operator which we use here is called tilde operator. Like this is how it looks. So for 1s complement, you just have to do, suppose if this is the bit x, then you just have to do tilde x, right? So this will give you 1s complement. And for 2s complement, you need to do nothing, just add 1 in 1s complement. So for example, you know how to get 1s complement from this, just revert all the bits, you get 1s complement, and to get the 2s complement, just add +1 here. So now whatever you will get, like here you will get 0 1 0 1 1. So this is going to be the 2s complement of this bit, right? So this is how 1s and 2s complement we calculate, right? So let's understand the importance of 2s complement, why we use 2s complement, right? This is important to understand, that why we use 2s complement. So in computer, for example, I have shown you that how we do addition. Like for 0 0 you can write 0, for 1 1 it will become 1 0. Okay, so for example, if somebody is giving you like add 8 plus 5, so you know how to do this, right? Because you know the addition in bits, how it performs. But if somebody is asking you 8 minus 5, now how will you do? So the basically what computer does is, computer basically understand it like this: 8 plus minus 5, okay, and then it gives you answer. Okay, so it again using the bitwise addition thing, but assuming now 5 as a minus 5. Okay, but the thing here is that the bitwise representation of bice. The bitwise representation of 5, but you don't know the bitwise representation of minus 5. How to write the bitwise representation of minus 5? So the thing here is that this minus 5 is nothing but the 2s complement of 5. I mean to say, so what here I am saying that instead of doing 8 minus 5, if you add 2s complement of 5 to 8, you will get the same result what you will be getting after 8 minus 5. Okay, so do you understand what I'm saying? So for example, let's check this, how why it works, right? So okay, so let's check this why it works. So for example, for 8, our bitwise thing, let's take some good example. Like suppose we are taking 12 and the second number which we want to subtract is 3. Okay, we want to subtract 12 from 3, 3 from 12, right? So let's write the bitwise manipulation, bitwise representation of 12. It will going to be 8, that's why 1, and then 4 will be 1, 8 4 12, and the rest will be 0, right? And for 3 it will be going to be like 0 0 1 and 1, right? I'm adding 2 zeros to make it look like equivalent, right? So now let's calculate the 2s complement of 3. Like what will be 12 minus 3? 12 minus 3 is going to be 9. Okay, so let's check what is the bitwise representation of 9, just like to recheck it. Like, so for 9 it is going to be 1 0 0 1, 8 plus 1 9, and that's why. So this is I'm doing it like with a shortcut method. So I have placed 1 at the 8th place, and I have placed 1 at the 9th, 1 at the 0th place, so that it can add up to 9, right? Now this is 9, so we are getting 12 minus 3, we know the answer 9. So we know after adding 2's complement of 3 in 12, we should get 1001, right? This is what we should be getting. Okay, so now do 1's complement. So in 1's complement, I told you, just reverse the bit. Okay, reverse the bit. So what will happen? At the place of 1 1, you will get 0 0, and in place of 0 0, you will get 1. But one thing is important here, like int is a 32 bit. So although I'm not writing the rest of the 28 bits, but it is there and it is 0 here, right? So while reverting the bits, you will have to make 1 1 1 1 1 here also till the 31st bit, because we are starting from the 0th bit till 31st bit, right? You have to make it 1 1 1 1 1, because int is a 32 bit variable. Okay, now let's make it 2's complement. In 2's complement, what you will do, you will add just 1 here. So when you will add 1 here, it will going to be like 1 0, and then 1 1 1 1 1 1 1 1 1 1, like till the 31st bit, right? Now let's try to add this 12 in this value. Let's see what I will be going to get. What will I going to get? Okay, so this is 1 0 0, this is 12, it was our 12, right? And the rest of 28 bit will be 0. Okay, and I'm writing my 1 0 1 1, and the rest bit will be same, going to be 1 1 1 1 till 31st bit, right? Now try to add this. When you add this, 0 1 will going to give you 1 0 0 0 1 1 1 1 will give you 0 here, but a 1 carry will get forwarded here. Now there are 3 ones, right? And for 3 ones, I've told you, for 3 ones you will get 1 1, means at this position you are writing 1, but a carry will get forwarded here, right? And this carry will, when get forwarded, you will get 1 and 1, which will give it here 0, right? And again 1 will get forwarded here. Now again 1 1 will become 0. Again a carry will forwarded here 1. Again 1 1 will be 0. So what will happen? So till the 31st bit, you will keep getting this 0 0 0, and because at the 31st bit, what will happen? Again you will getting 1 1, and you will get 0. But this time the carry which will forwarded is going to be discarded, because there are no any places after 31st bit, so that carry will get discarded, and you will finally get this one, this value 0 0 0 0 0 0 0 and 0 1 0 0 1, and this is nothing but your this number. So as you can see, you are getting 9 here also. So this is basically the concept of 2's complement, that instead of subtracting that number from the original number, just add the 2's complement of that number, and you will get your desired number, right? So this is how it happens inside the computer, that instead of subtracting it basically adds that number, the 2's complement of that number, right? Now let's understand some operators now, like what is AND operator, what is OR operator, what is XOR operator, and what is NOT operator. Okay, now let's understand this. For AND operator, what happens? Basically, suppose this is AND operator. Okay, so it takes two values, A and B. Okay, it takes 2 bits, A and B, from 2 different places, and it returns a single value, right? So suppose if you are giving it 0 0, it will return 0. If you are giving it 1 0, it will again return 0. Okay, if you are giving it like 1 and 0 and 1, it will again return 0, and if you are giving it 1 and 1 from both sides, it will return 1. So in case of AND gate, the thing is that if any of the bit is 0, then you will be getting 0, but if both the bits are 1, like in this case 1 and 1, you will be getting 1, right? So this was the concept for AND gate. Now let's take the OR gate. OR gate is basically, it also takes 2 values, A and B, and it returns a single value. Okay, so suppose if you are giving it 0 0, it will return 0. If you are giving it 1 and 0, it will return 1. If you are giving it 0 and 1, it will again return 1, and if you are giving it 1 and 1, it will give 1. So in this case, you can see if either of A and B is 1, you will going to get 1. As you can see, either of A and B is 1, you will going to get 1. But if both of them are 0, you will going to get 0. Right? So this is basically for the OR operator. Right? Now let's see for the XOR operator. What is XOR operator? Right? So in XOR operator, what happens? So suppose it also takes two values from A and B. Okay, but if you are giving it like 1 and here also a 1, it will return 0. But if you are giving it 1 0, it will give you 1. But if you are giving it 0 and 1, it will give you again 1. But if you are giving it 0 and 0, it will return 0. So in this case, the concept is that if both the bits are same, for example, if both the coming bits are same, 1 and 1 or 0 and 0, if both the bits are same, then you are going to get 0. Then you are going to get 0. Okay. But if both these values like 0 and 1 are different, like from one side I am getting 1 and the other side I am getting 0, then you will get 1. Right? So this is basically the XOR gate. And for the NOT gate takes the single input. So this is NOT gate. So for if you are giving it 1, it will return 0, and if you are giving a 0, it will return 1. Right? So this was basically the AND or XOR NOT operator, which we use in bit manipulation. Right? So okay. So now let's move on to the next thing, which is now let's move on to some CP techniques which we use to do some problems. Okay, let's see some CP techniques, or you can say some tricks which we do. Okay, so before doing this, let's first understand how we traverse any bit. Okay, how to traverse or how to set, unset, how to set, how to unset, or how to toggle a bit. Okay, I know that I'm writing very bad, but I can't do anything in this. So okay, so before learning all these 5, let's first understand about left shift operator and right shift operator. This is basically our right shift operator because the direction is in right, and this is basically our left shift operator because the direction is in left, as you can see from here. Right? Okay, so now let's understand what is left shift operator and what is right shift operator. Right? Okay, so basically what happens, left shift operator does. For example, if I have given you 5 and I said right shift operator 1. Okay, so what will it do is like for example, in 5 the binary representation of 5 is 101. Okay, so it will just shift the one bit to the right. So what will happen, initially it was like 0 0 0 0 0 1 0 1. So a single bit, the rightmost bit will get discarded 1 because there is 1. So I have discarded the 1th bit from here, and the new value will become 0 0 0 1 0. For example, if 2 was written here, so what you had done is like you have discarded 2 bits from the back side. So it would have become like 0 0 0 1. Right? So basically what you are doing, you are basically removing these number of bits from the back. If we are doing the right shift operator, we are moving this number to the right. That's why you can understand in that way. And suppose if somebody says the left shift operator, right, like 5 5 5 and 2, somebody is saying this. So initially the value of 5 is 101 in binary representation. So after somebody is saying that left shift 5 by 2. So what you will do, you will just left shift every bit by 2 bits. So what will happen, the two new 00 will add on the right side. Okay, so here it will become 1010100. Okay, for example, take another example. Suppose this is 3 and somebody is asking you what is the value of after shifting it by 1. So initially 3 was 1 1. Now after shifting by left shift operator by 1, it will become 110. I have added 10 here because I have to shift it left by 1 bit, right? Now understand what happens on the number itself. What happens the number itself? Okay, so here we are seeing this is in binary form, right? So for example, whenever you left shift any number by 1, okay, so you are doing what you are doing. You are just the new number will become 5 into 2. You just multiply it by 2. It will become 10. So basically this number is representing 10. If somebody is saying 5552, okay, what this is representing? This is representing 5 into 2 to the power 2, because you are saying to shift it by 2 times. Okay, if somebody is saying 5 into 5 left shift operator 3, so it will become 5 into 2 to the power 3, right? In the similar way, if somebody is saying 5 right shift operator 1, okay, 5 right shift operator 1, so this is nothing but 5 by 2, which is basically 2. So now it became 2. This value is representing 2. Why? Because you can see here also, when I have moved 5 by 1 this side, so initially it was 101, and when you have removed the 1th bit from the back, it become 10, and which is equal to 2. So that's why you get 2. So remember it that you are always going to get the lower bound of the number. For example, 5 by 2 is 2.5, but you will not going to get 2.5. You will going to get 2 only here. Okay, and if somebody is writing like 5 of 2, it is basically nothing but 5 divided by 2 to the power 5 divided by 2 to the power 2, right? So this is how we calculate these things. Okay.